Welcome back. In this video, we're going to continue with our Unit 2 and 3 test cumulative review. So we already talked about hypothesis, conclusion, and how to manipulate a conditional statement to make the converse, the inverse, the contrapositive. And we discussed the difference between inductive and deductive reasoning. In this video, we're going to move on to the second part of Unit 2, and we're going to look at some linear relationships and equations. So the first one, number 7, what is the relationship between each of the pairs of angles below? So the first one I'm looking at is angle 10 and angle 14. Okay, so here's angle 10 and here's angle 14. To get from 10 to 14, from my blue eraser to my orange eraser, I have to travel along line S. So that is my transversal. Okay? I can see that both of those erasers are on the same side of the transversal. Okay, so that means we're not an alternate interior or an alternate exterior, we're on the same side, which means we're either same side interior or we're corresponding. Same side interior would have to be on the inside of both of those other two lines that are being crossed. So that means this tells me that these are corresponding because they're both above the transversal and they're both to the right of P and Q. So these are corresponding angles. Okay? The next one is asking about 3 and 9. So here's 9 and here's 3, which means now my transversal, to get from 9 to 3, I have to travel along line P. Okay? So now when I look, I can see that my blue eraser is on the left of that line, my pink eraser is on the right, so these are definitely alternate. I need to decide, are they interior or are they exterior? So my other two lines are R and S. I can see one is below R and the other is above S, so they are inside the two lines, so they are alternate interior. Okay? The next one wants 10 and 13. Here is 10, here is 13. So the line to get from 10 to 13 is line S. That becomes my new transversal. Now those two lines are both above it, so that's not going to be an alternate. It's going to be either same side interior or corresponding. Okay? Since they're both inside the other two lines, they're inside these two lines, we say they're same side or consecutive interior. So you can either call them same side interior or you can call them consecutive interior. We'll say or. Either term can be used. Okay? And then the last one is going to be angle 4 and angle 2. So when I look up here, here's angle 4, and here is angle 2. Now angle 4 and angle 2 are at the same intersection. So that means there is no transversal. I can get rid of this line completely. There is no transversal to get from 4 to 2. They're right here at the very same intersection. They're across from each other, not next to each other. If they were next to each other, that would be a linear pair. But they're across from each other, which means they are vertical. Okay? All right, let's look at number 8. Number 8, when lines are parallel and crossed by a transversal, which of the following angle pairs are supplementary? Okay? Well, corresponding angles are congruent, so it's not that one. And again, this is only when lines are parallel. Alternate interior angles are congruent, so it's not this one. Alternate exterior angles are also congruent, so it's not this one. My consecutive interior, which remember are also called same side interior, it's the one that has two names, so it's the one that also is different from the other three. The same side or consecutive interior angles are supplementary. So this is the pair that would be supplementary. Okay? let's look at the next set of questions. Number 9, write an equation of a line that contains the points 3, -5, and 7, 3. And the first one wants it in point slope form. So remember, our point slope form is y minus some y value that's given to me equals the slope times x minus some x value given to me. Okay, so I have 2 points, 3, -5, and 7, 3. And I can tell that I am looking at a y1 and an x1, and I have 2 y values and I have 2 x values. So I just pick whichever one I want to pick. My problem comes on this problem in the fact that they didn't tell me what the slope is. So I'm going to have to compute my own slope. So when I do that, I'm going to subtract my y values starting with the second one first. So 3 minus -5. And I know I already have the minus there, but you still have to do the -5. And then we do our x values. 7 minus positive 3. Okay? Remember right here, this is super duper important, that when you have the minus and negative, you make sure that you turn that into a positive. So it's really 3 plus 5 on the top, which is 8. And on the bottom, 7 minus 3 is 4. Okay, so 8 divided by 4 is just 2. So I know that I'm going to replace the slope with 2. Okay, then we get to pick whichever point we want to pick. I personally like to go with the positive answer, because that way I don't have to worry about my negatives. And I'm going to replace the y1 and the x1 with the y and the x. So when I fill this in, I'm going to say y minus equals, and then x minus. If I use the second point, my x value 7 goes with x, my y value 3 goes with y, and here I don't have anything to simplify. That is my final answer. Okay, if I had chosen this first point, y minus something equals my slope, which we already found to be 2, it's still the same slope, times x minus something, parentheses. So if I use that second one, then we're going to have the first point, my x value is 3, so 3 goes with the x. My y value is a -5. So I can't put a box around this one because I still need to simplify this right here. So when I finish this, I'm going to say y plus 5 equals 2 times x minus 3. Okay? Now for my slope-intercept form is just y equals mx plus b. Okay? So that means you just have to take one of the previous equations that you wrote and solve it for y. Okay? It doesn't matter which one you pick because you're going to get the same answer either way. So let's say I go with this first one. Y minus 3 equals, I'm going to distribute this in. 2 times x, and then 2 times a -7 is minus 14. Okay? Then I'm going to add 3 on both sides. And I get y equals 2x minus 11. So that is my answer, and I would be done. Okay? But just so you can see, you don't have to do this on the test, but just so you can see that it doesn't matter which point you use, I'm also going to go ahead and solve this one. So I'm going to do y plus 5 equals, I'm going to distribute this in, 2x, and then 2 times a -3 is, 2 times -3 is -6. I'm going to subtract 5 on both sides, and that leaves me with y equals 2x minus 11. So either way, either point you use up here, you'll still get the same answer when you solve it for y. Okay? All right, we're going a little long, but we have one more question in Unit 2 section of the review, so I want to do this last question. Circle the equations below that are perpendicular to the graph of 2x minus 5y equals negative 7. So what I need to do is I need to solve this equation for y so that I can find out what its slope is. So I can see the y equals mx plus b. I'm going to move I'm trying to get y by itself, so I'm going to subtract my 2x on both sides, which is going to give me a minus 5y equals, I can't put these together because one has an x and one doesn't, so negative 2x and then a negative 7. And then I'm going to divide everything by negative 5. Okay, and what I end up with is y, 1y, equals negative over negative is positive, and then 2/5 doesn't reduce, so it stays 2/5 x. And then negative over negative is a positive, and I'm just going to leave this as the improper fraction as opposed to changing it to a decimal, and we never ever want to change it to a mixed number when it's in an equation. Okay? So the slope I'm looking at when I look at this equation is 2/5. That's my slope. So that means my parallel slope would also be 2/5. And my perpendicular slope would be a negative, and then you flip it over, 5/2, so that this one's positive, this one's negative, and they're also the reciprocals, so they're opposite reciprocals. So it wants me to circle the equations of the graphs below that are perpendicular to the graph. So I am looking to circle any equation that has a slope of negative 5/2. So here's a negative 5/2. Here's a negative 5/2. Now that one's close, right? But it's 5/2, but it's not negative. Here's a negative 5/2. Here's a negative 5/2. And that one's close, but it's positive, and I want negative. And that one's close, it's negative, but it's not flipped over. Okay? Now, I know it didn't ask me to, but I'm also going to point out, do we have any parallel lines? Parallel lines would be 2/5. So this one is parallel. This one is close, but it's negative 2/5, and we want positive 2/5. We want positive 2/5. This one is parallel. Positive 2/5. So I only have 2 lines that are parallel. Every other line there would be considered oblique. This one's oblique, which means they intersect, but not at a 90-degree angle. Oblique, 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 and oblique. They intersect, but not at a 90-degree angle. Okay, and then those circled ones, remember it did ask me to find all the equations that were perpendicular. So the circled ones, when we're looking back and reviewing, those are the ones that are perpendicular according to their slope. Okay, hopefully that helped you. In the next video, we will begin looking at the Unit 3 review, okay, for the test that you're going to be taking tomorrow. All right, thank you so much for watching.